Can I say again?
Okay. Can anyone
Hello.
explain me the difference between regression and classification?
Ma'am, can I say?
Yes, please.
The difference between regression and classification is in regression we focus on problems in which we need to find a specific value, like we need to predict a car's price, then we will use regression. Whereas if we want to classify whether a person has a specific disease or not, then we will use classification method. In classification only, there are few classifications, like whether it is there or not, or whether it belongs to a certain category or not. But in regression, we get a specific prices or specific number.
Okay, fine. So in the short, as I said, supervised is comes under supervision, unsupervised comes in self. Okay. So regression means, in one word, if you want to say, regression is for continuous output. Okay. And classification where you need to classify output. Okay. So in regression, you will get the continuous output. The values will be continuous. Okay. For example, it may be weather. Okay. So means it can change. It may be share market values, which can change and the values are continuous. And for classification, they are divided into class. Like this is 1, this is 2. Okay, there means either it is in 2 class or in more classes. Okay, so output can be different, but in classification, you will get classes at the output, maybe 2 or more. Or if the values is continuous, it comes under regression. Okay, is it clear up to this? Okay, so the next part means today what we are going to see is classification. Okay, so basically there are many many classifiers. Okay, so let's see the main. First one is binary classification, as I told. Okay, which means we are dividing output in the 2 class, right? That is yes or no. Okay, the next one is multi-class classification. Okay, so here output may be in multiple forms. Okay, so it may be like if you anything more which is more than 2. Okay, so the next one is multi-label. Okay, so these are the main classification. Okay, where you can say the multi-class in the binary, as I told you, that it is in the 2 yes or no, true or false, or anything which comes between 2. Okay. Where is the pencil? Okay, so the graph of linear regression is this, like this. Okay, like this. And for binary classification, it looks like this. Sorry, not like this. Just like this, means either it is 0 or it is 1. Okay. So this comes under binary. And for multi-classification, there are many methods. Okay. So you can say the cluster method is there, KNN method is there. So if you plot your scatter plot, and if your output is like in sorry. Okay. So if you plot any plot, and if your output looks like this, means there are so many data here are also data, here is also data. Okay, so you can say that this is one category, this one belongs to another category, this is another category, this is another category, this is another category, and this one is another. Means you can see your output is divided into 1, 2, 3, 4, 5, and 6 categories. Okay. And the multi-label is, means there will be 2 classes. Okay. So if, for example, if your the main class is fruit, okay, so it may be depend on like red fruit, blue fruit. Okay, we can classify it. For example, if it is motorcycle, or if it is yes, if we take the example of any particular bike, so it can classify it multi-labels like blue bike, red bike, or yellow bike. Okay, so this comes under the multi-label classification. Okay, so there are so many things which I want to share, but let me check. Okay, so I'll share one image with you. Let me check, which will show you the same. Yes. Is my image is visible, or only the screen is visible?
Only screen is visible.
Green, ma'am.
Okay, fine. So is this image is visible?
Yes, ma'am.
So you can see this is the example of classification, means it will classify your all the data in its particular class, right? Sorry. Okay, so this is the one of the example of simple example of classification. Okay. And another thing I want to share is wait. Okay, is my screen is visible?
Yes, ma'am.
Okay, so can you see this classification versus regression image? Okay, so this is belongs to your classification. Okay, this is example your classification, and this is your regression. This is your linear regression. Okay, so in your regression, your data is continuous. Okay, and in classification, there are only 2 classes like spam and not spam, right? Okay, so there are so many images you can get from the internet. Okay, I have sorted few of them. Yes, this is also one of the example of classification. Okay, so you can see in the classification section, you are drawing this curve, right? And here in linear regression, straight line is there, right? So is my screen is visible?
Yes, ma'am.
Okay, so I'll explain that about all the things, what is called ROC and AUC, okay? So let's move towards our main. Yes. So these are the topics we are going to cover, okay? So as we know, the supervised machine learning algorithm can be broadly classified into regression and classification, as I already explained previous. Okay, in regression algorithm, we have predicted the output for continuous value, but to predict the categorical values, we need classification algorithm, right? These all the things I have explained previously. Because that whiteboard is not working, that's why I need to text here, right here. Okay, so these are the example. Is my screen is visible?
Yes, ma'am.
Okay, so these are the all example of classification algorithms. Okay, like linear. Okay, there are two types: linear and non-linear models. Okay, so in linear model, as that line will linear.
Hello, ma'am.
Yes.
Ma'am, please explain the difference between multi-level and multi-class.
Which one?
Multi-level and multi-class.
Okay, fine. Okay, so if meeting ends in 10 minutes, please join. Okay, so for multi-class, okay, I'll share the image which I have already downloaded. Okay, is this image is visible? Hello.
Yes, ma'am.
Okay.
Yes, ma'am.
So yes, you can see here multi-class classification and multi-label classification. Okay. In the multi-class, you are classifying one single object. Okay. For example, if it is color, then you are classifying it red color, green color, or blue color, right? Yes. And in multi-label classification, you are classifying that particular object, right? Means color you are classifying, but along with that particular label, means car. Okay, so it may be red car, green car, blue car. Okay, and here red is one class and that car is another class. Means it may be bike, it may be bus, it may be luxury, whatever. So there are two different things. You can say this works like dictionary. Dictionary concept, you know, right? Where keyword is there, which belongs to particular dictionary, right?
Yes, ma'am.
Okay, so in dictionary we have to write its keywords. So likewise in multi-labeling, we are classifying that particular object along with its label. Okay, actually this label classification comes under the image part. If you are familiar with image processing, okay, so this label encoding is there, yes, labeling part is there, where what we do, okay, my internet connection. Am I audible? Because it's showing my internet connection is unstable.
Yes, ma'am.
Okay.
So,
So,
ma'am,
what,
we can say, like in multi-class classification, we'll get one result, and the multi-label classification will
no.
get multiple results.
No. In multi-class classification also you are getting more than 2. If it is more than 2, it is multi-class.
Yeah. Ma'am,
Okay.
I'm saying that the result will be one only, no? Like we are classifying the classes like red, green, and blue. Then we'll get one output.
No.
And in
If it is
multi-label, there are 3
classification,
categories.
no, see, if you are classifying using the multi-class classification, result are also 3. Red,
Okay.
green, and blue.
Mhm.
But in multi-label classification, you will get 9 outputs. If your inputs are 3, means red, green, blue color, and car, bus, and bike is there, so you will get accordingly output. Means red, green, car is for red, green, blue. Okay. Bus is also red, green, blue, and bike is also red, green, blue. Right?
Yes, ma'am.
So you will get multiple outputs. Means if here are getting 3, so here you will get in multiplied by its label.
Right. Yes.
Right?
Yes. Yes, ma'am.
Yes. So if you people are familiar with image processing, so there is concept of labeling image. Means it is also comes in supervised learning. Anyone is familiar with OpenCV for image processing?
No, ma'am.
Anyone knows what happens there?
Ma'am, that is cross-fold. Is
Sorry?
it?
No, that is different thing. Open CV is different thing, and that CV means cross value, that is different thing.
Okay.
Okay. What happen in that open CV? What we do? See, we use open CV or image classification for counting people or for sentimental analysis. Okay. For example, if 10 students are there in particular class, so how many students are happy with the class? Just by reading their faces, we can detect it. Okay, so these all parts comes under the image classification. Or else you can see if if traffic is there, or if you want to count the number of vehicles, or if you want to count the number of vehicles along with their categories. Okay, means first thing, if car is there, you have to put 1 in the car box. If another bike is there, then you have to put 1 in the bike box. Okay, so let me explain you. Okay, fine. I'll explain it shortly as soon as possible. Okay, and if cycle is there, then you have to put 1 in cycle box, right? So next time when car came, so the count for the car box will be 2, right? So what you are doing there, you are counting that vehicles along with their categories, right? So for that, for teaching machine, before you have to first collect the images of all cars. You have to collect all the images of cycles. You have to collect all the images of what was third? Bike, right? Likewise, you have to count all the images. Means cycle, car, cycle. Okay. So this is for your cycle. And this is for example, this is your bus. Okay. So this is for your bus. So every time a new vehicle come, you have to put it in car. If cycle came, it will burn. If bus came, it will burn. Is my screen is visible?
Yes, ma'am.
Okay. So if another car came, here it will be 1. Here, if if bus came, here it will be 1. Likewise, it will count. At the end, you will get, there were 2 cars, there was 1 cycle, and there was, for example, 3 buses. So for making this classification, what you have to do in previously, you have to download all the images which show the car. You have to download all the images which shows that what is cycle looks like. Okay, you have to download all the images related to bus. Means its front view, its side view, its top view, its bottom view. Means even if the corner of car is visible in your CCTV camera should know that this is a car. Okay, so all images you have to provide to machine, means this is folder for all car images, this is folder for all cycle images, and this is for bus images. So this images, it's called as your pre-data, means test data. Okay, and you have to do annotation for it. Yes, image labeling is called annotation. I was like thinking what is called. Yes, you have to do annotation, means each, if there is car, you have to make the box around that car and you have to write it is car. And this all happens, or this all done in one application. For image annotation, application is there where you can annotate your image according to your input or according to your project. If you are like vehicle detection, so you can classify it likewise. If you are having the project of tumor detection, then you have to annotate the tumor, like which is that. Okay, if you are making the project on RBC, WBC platelets or complete blood count, so you have to take the images of that blood samples. You have to classify that which how RBCs look like, how WBCs look like, and how platelets look like. Okay, so that this is called your raw data. Okay, which is called as test data. Then once you done annotation, then you have to classify this data into two types, like train data and test data. Okay, so you have to train your model by using this data so that your model knows how car looks like, how cycle looks like, and how bus looks like. Then, okay, then you can test it. For testing, you can use unlabeled image as well, where you can find if you provide a random car image